Whether you are using your computer for gaming or like me for mining, sooner or later you will face the problem of overclocking your graphic card. And if you have more than one GPU and your system of choice is Linux, this is when the real challenge begins. In this video, I will walk you through the process of overclocking multiple Nvidia graphic cards under Linux, and at the end of this video you will be able to do it yourself within several minutes. Let's go! It's been a while since my last video. Actually, I was working on different projects, which I will also try to describe on my channel. This video, however, is the last one in the series of 4 videos related to my mining farm setup. If you are interested to see how I set up my Linux-based mining farm with remote access and Raspberry Pi as a router, please watch other 3 videos from the series on my channel. Okay, so let's go back to Nvidia GPU overclocking. When I first started to investigate the problem, I found multiple information sources, but all of them were outdated or just some pieces of the puzzle, but nothing complete. So in this video I will try to gather everything in one place. To get started, we need to have installed the required software. We will need Nvidia proprietary drivers that you can download from Nvidia web page, utility called nvidia-settings, and utility called nvidia-smi. If you are using Ubuntu, you can install Nvidia drivers by installing Nvidia driver package. The package for Nvidia settings and nvidia-smi has exactly the same names. Once the necessary software is installed, we can start configuring Xorg server. Under Linux, it is not possible to load the driver for the graphic card without starting Xorg server. At least there is no such possibility known to me, so configuring Xorg server is a must. To do it, after logging as a root, just run the command x-configure and it will auto-detect all graphic cards available in the system and will create a default config file which you can see here. By the way, X server failed to start in this case because it is already running. But if it starts for you, you can stop it by pressing simultaneously Ctrl, Alt and Backspace. Next, let's have a look at the config file that was created. We immediately can see that 9 screens were identified. This is because screen 0 is for graphic card embedded into the motherboard, and the rest are external graphic cards. So all these sections we can leave without a change, and we need to scroll down to device section. Okay, this device section is for embedded GPU. The driver is Intel, so we are skipping it. Scrolling down, and here is the first place where we need to do the change. Nouveau, this is how I believe it should be pronounced, is an open source driver for Nvidia GPU. It does not allow overclocking and power management. Please correct me if I'm wrong in the comments. So we will use Nvidia proprietary driver. Additionally, we need to set up coolbits to tell the driver that we want to allow overclocking. This is done by adding the following line: option coolbits 12. Now we need to repeat this step for all device sections further in the file. Once all device sections were updated, we can finish editing the file and save it. However, to start Xorg server, real monitor need to be turned on and attached to the at least one graphic card. Otherwise, X server will fail because it will not be able to detect any working screen. So to achieve real headless setup, where no monitor is needed to start Xorg server, we need to have so-called extended display identification data file and provide this file to xorg.conf. But how to get this EDID file? You can try googling it for random monitor, or you can start your system with the monitor attached and copy existing information of your monitor ID. First try this command. If it finds file with a non-zero size, then you are lucky and you can copy this file. If you get only zero-sized files, like in my case, you can use Nvidia setting tool to save EDID file. Just start Xorg server, after you edited Xorg file of course, and then start NVIDIA settings tool from the terminal. By the way, in my example I am starting it remotely, what you can notice in the command line parameters. In this tool, search for the GPU that has DFP section. It means that monitor is attached to this GPU. Here we have it. This is in monitor, and now you can press acquire a DID button to save a DID file. After a DID file is saved, open xorg.conf file again and add these two lines to monitor section. It is not that you add it just to one monitor section, there is no need to add it everywhere. And obviously you need to replace this path with appropriate path of a DID file on your computer. Save the file, and now you can start Xorg server even if no monitor are attached in so-called headless configuration. Once Xorg server is configured, this is where the real fun begins. To start overclocking your Nvidia graphic card, you can just use Nvidia setting graphic tool. It is very intuitive, but it will not reload the settings after you restart X server. As written in the manual, this behavior is intentional because different users may have different preferences, but there is a very simple solution for this. When you quit UI, the settings are automatically saved to a file called nvidia-settings.rc, and you can load them back with this simple command line: nvidia-settings --load config only. To load settings automatically, just put this line inside xinit.rc file. After loading the settings this way, you can also check the values and change each and every GPU parameter with the command line. Here's the list of commands that I used while tweaking my setup. As you can see, I'm still using Nvidia settings tool with some additional parameters. -q here means query and -a means apply. Then, in the square brackets, we need to provide GPU ID to which the setting will be applied. This, for example, means query all available GPUs, and this means query only GPU 0. If we want to query some specific multiple GPUs, we need to repeat -q and appropriate parameter with another GPU ID multiple times, like in this example. So with Nvidia settings we can manage main clock and memory clock, but to manage power settings we need to use nvidia-smi tool. I'm using it to query GPU temperature and fan speed, also to set persistence mode. However, to set fan speed I'm still using Nvidia settings tool. Okay, so this is very quick overview of Nvidia command line tools. I showed only the major use cases and parameters, but there are much more. If you want to use these tools, you obviously need to study manual pages for those tools. I will give you just one additional hint. To list all available settings for your GPU, you may want to use command nvidia settings --describe = all. Well, that's all folks. I hope you will find this video useful. If you have any questions, just ask them in the comments. I'll try to help if I can. By the way, all comments shown in this video you can also find in the description. And don't forget to give likes to this video and to subscribe to my channel. See you in the next video related to my projects, where you will probably see more geeky electronics, soldering and computer related stuff. We'll see. Bye.